We're asked to find extreme values, so that means we want to take a derivative. And wherever the derivative fails to exist, or wherever the derivative equals zero, those are critical points. And critical points are important because they tell us potential maxes or mins. Maxes and mins, they can only happen at critical points if it's a continuous function, or at the endpoints. So taking a derivative, the derivative sign is cosine, and then the derivative of the innermost function is going to be a 1, so we're not going to have to worry about that with the chain rule. Okay, so there's our derivative. If we set this equal to 0, then we're supposed to find all the values that would make cosine equal 0. And so if you're not sure how to find these, think about the unit circle. Cosine is the x-coordinates in the unit circle. So if you have an angle of 0, which means if the entire inside of this parentheses equals 0, then cosine is going to be 1, right? We want to set this equal to 0 though. So let's rotate. Right here, this point is 0, 1 on the unit circle. So a 90-degree angle, in other words, pi over 2, would make cosine equal 0. So we want this inside to equal pi over 2. So we just have a little equation to solve. Oh, sorry, that's pi over 4. We want to set this equal to pi over 2. If we can find an x that would make this equal to pi over 2, then cosine pi over 2 equals 0. Right? If you solve by subtracting that pi over 4 from both sides and do your fraction work, you get negative pi over 4. Okay, that's not in our interval, so let's keep looking. Okay, this right here, cosine would be negative 1. This right here is 3 pi over 2. So this is another place where cosine would equal 0. So we want the inside of this parentheses to equal 3 pi over 2. So if you solve that by subtracting that pi over 4 from both sides, you want common denominators. So 6/4 subtracted by 1/4 gives us 5/4 pi. And that is a number within this interval they gave us, right? And you could check me too. If you plug in pi over 4 plus pi over 4, sorry, if you plug in 5 pi over 4 in for x plus pi over 4, that makes 6 pi over 4, which is 3 pi over 2, which is 0 if you check that with a calculator. All right, so we found a critical point. We took a derivative and we set the derivative equal to 0 and we solved x equals pi over 4. So we want to check to see on this interval, here's 0, here's 7 pi over 4, and then we want to check 5 pi over 4. Because the maxes and mins can only happen at the endpoints of the interval or at the critical points. So if you plug in 0 into the original function to find out, how high or how low we are, then you're doing sine pi over 4. Pi over 4, that's a 45-degree angle, right? And so when you do a 45-degree angle in the unit circle, then you're talking about side lengths with square root of 2 over 2. That's one of the few things that we have to memorize and we can get by with all trig. Because pi over 4, look, I plugged in 0. That's what I did to start this off. Pi over 4 is 45 degrees, which means for our reference triangle, we have square root of 2 over 2 for the two side lengths that are not the hypotenuse. So opposite divided by hypotenuse, I get square root of 2 over 2. So 0, square root of 2 over 2. And you could verify that with a calculator too. Okay. And then we got 5 pi over 4 to plug in. So if we plug 5 pi over 4, we've already actually done that one. No, we did that for cosine, sorry. 5 pi over 4 plus pi over 4 gives us 6 pi over 4, which is 3 pi over 2. Sine is the y-coordinates in the unit circle. So this is 0, negative 1 here. So if you plug in 5 pi over 4 into the original equation, you get negative 1. So it looks like this might be a minimum, but we still got to check by plugging in 7 pi over 4 in. If you plug in 7 pi over 4 into the original equation, that gives you 8 pi over 4, which is 2 pi. So that's a full revolution of the circle. Sine is the y-coordinates. So right here, this is at 0. Okay, so now we can say what the maxes and mins are for the entire function. What's the lowest y-coordinate? Lowest y-coordinate is negative 1. So at 5 pi over 4, we reach a minimum on this interval of negative 1. Okay. I'm just double checking because sometimes I mess stuff up. No, that's right. Okay, because that's the lowest y-coordinate. The highest y-coordinate, according to our analysis, is square root of 2 over 2, so this is the maximum. The maximum occurs at 0, but this is not what the book. 1 second. I found my mistake back here when I solved this equation. I missed a critical point. Look, when you solve x plus pi over 4 equals pi over 2, that doesn't make negative pi over 4. That makes pi over 4, right? Because this is 2 pi over 4 subtracted by 1 pi over 4. So I missed a critical point. So these are all still true, but I needed to test pi over 4. And then we got 7 pi over 4. So we've already tested all those ones. And I imagine if we plug in pi over 4, that's why I get something different from the book. If you plug in pi over 4 into the original equation, pi over 4 plus pi over 4 makes 2 pi over 4. So that's sine pi over 2. Okay. And the sine pi over 2, that's a 90-degree angle. So that's 1 for a y coordinate. So if you plug in pi over 4 into the original equation, you get 1. And then here's our other ones, 5 pi over 4 comma negative 1. And then we got 7 pi over 4 comma 0. Okay, so the minimum of this on this interval right here, this is the lowest y value we can get. So that's our minimum. The maximum, the part that I missed, I dropped a critical point on accident, is at y equals 1. So that's the maximum on the interval. And then these other 2 points, you could say that they're, well, let's see, if you're going from square root of 2 over 2, that's a little bit less than 1. So this would be a local minimum, and this would be a local maximum. But the global max, or the max and min for the entire interval are just these 2 points I just pointed out, because those are the highest and lowest y coordinates.